So now we have a circuit I've been thinking of for a while. I finally wired up a prototype. So there's not going to be a schematic diagram, but we're going to go over the circuit in detail. So right now you can see that these two LEDs are flashing. That's a 555 timer wired in astable mode. Both of these are. And these are the same value capacitors, even though that one looks larger. It can probably handle more voltage. But in any case, there you can see those two LEDs are flashing. This is a remote control module. Here's the remote. There's the antenna. And when I press A, because of how I programmed it, now you can see that this upper 555 timer is the one flashing the LEDs. This one is just the blue LED. It's being held low because we have it being reset right there. And then if I press B, now this one's the one alternating. That one's held low because we have the 555 timer reset. When it is reset, that means pin 4 there, the reset pin, is connected to ground. So right now the transistor is on, which tells me that the relay there is off. So we're just using the one that connects to ground, the negative supply. That's the white wire there. You have to power the module. I'm powering it with the same power supply that's powering the breadboard. We're only using 5 volts. I think this can go down to like 3.6 volts. So 5 volts is plenty 5. But in any case, this is always the positive wire. It's always going to be positive, and you can wire a load, come back to the white jumper for the negative, and it's either connected to negative on or else it's not off. So in any case, we determined that right now it is not conducting, and thus that allows the NPN bipolar junction transistor here to be on. The other end is connected to ground right there, and therefore the output is held low there. Now I'm going to press A, and so now this one is flashing right there. So that tells me that the transistor is not on, because this one, pin 4 there, the reset pin, is coming over here to where the white wire is. So that is ground right there. The switch to ground, basically, to the negative supply. So if it's connected to ground, so it's on, ground will come there because we have a pull-up resistor there, but we have a direct connection to ground. So that's resetting the 555 timer, holding the output low right there. Hopefully that makes sense. But any case, I'm thinking of taking the outputs there, setting different timing. Right now they are the same timing. Basically, they might be, slightly different due to a different, tolerances of components and stuff. They aren't perfectly the same. But in any case, they should be pretty close to about exactly the same. I could have one that goes a whole lot faster, another one that goes slower, and then we could use like a diode to only let the high outputs go. And then, if that'll go to something else. So it'll really be either like slower or faster, depending on which 555 timer is on. Hopefully that makes sense. But for now, we're just going to look at the flashing LEDs. So right now, it is B. And before I forget, so this is a programmable module right here. You have to reset it before 1, 2, 3, 4, 5, 6, 7, 8. That resets it before you put in a new program. So now I'm just going to do 1. And so it's lit. I'm going to press A right there. And now, if I don't press A, this one is flashing there. This will turn the relay on right there. And now you can see the other one is flashing. But as soon as I release it, now that one's flashing. Now we're going to try to go back to 1, 2, 3, what I had it set. So now it's going to look like we can program it. So it's asking to press a button. Now it's asking to press another button. And if things went well, we would not have this problem. You can see, as long as I hold the button down, we have what I set before right there. So it didn't reset it. It's just responding to when I hold down A. So you got to do 1, 2, 3, 4, 5, 6, 7, 8. Make sure it's flashing a bunch of times. Now, 1, 2, 3 is the program I want. There we go. A. So this was really confusing me. I was wondering why it wasn't doing what I wanted to, which is this. So A gets that one flashing, and then B gets that one flashing right there. So now we'll zoom in. This capacitor is just helping make sure the board maintains 5 volts because when you suddenly drop power and stuff, especially if these capacitors are larger or something, then it may throw off the voltage a bit. Probably can go without this capacitor in the circuit, but it helps maintain the voltage of the power supply. Otherwise, it's not actually doing anything. So here you can see that output is staying low right there. So we know that this is connected to ground to the negative supply in some way. If I remove this, then it's going to flash. We have this pull-up resistor right there, 10,000 ohm resistor. And the timing resistors are also 10,000 ohms. Those are 100 microfarad capacitors. Again, that one's just bigger. Probably can handle more voltage. But in any case, they're setting the timer where the output is about high and low once a second right there. So they're both flashing now until I put the jumper back. So we know the jumper is connected to ground. Let's see where it's going. So that's going to the transistor. So the transistor is on. You can see, so this is a 2N2222 collector base emitter. And the base, you need a little bit of current going through the base to turn it on. So the current's going to flow through there. And that makes a connection to ground when it's on. And when it's off, then this is, off. It's not connected to anything. And then the pull-up resistor can, do that. Can alternate the LED. So that's how that works. Now, the resistor coming to the NPN bipolar junction transistor base right there is coming to the output there. So that's connected to ground when the relay is on right there. So the other state, not the one we're in right now. And so we get a connection to ground that turns off the transistor, makes it so it does not conduct. And then we got ground over here. So it's not conducting. It's like this jumper's gone and that one's flashing. So hopefully that makes sense. So during that time, then this one will be connected to ground. And you can see here that we have, I short-circuited something. So the power supply shut off. I can just turn it back on. That's what happened. So we didn't get a spark because I got current limited, and also the power supply shuts off. So in any case, when this one is flashing there, now we know that this is not getting connected to ground right there. We have a pull-up resistor there. We're getting the positive supply. And also, that's coming over to this resistor right there to provide the current for the base. Without this jumper there, now you can see the transistor is off. We need this current path, that resistor, and then this one, the way that I have this wired up right here. And then when I press the button, then so yeah, this is connected to ground right there. That means we're connected to ground there. The ground's also going to the base of the transistor right there. And because this pull-up resistor, whatever current gets through, just going to go to ground now that the relay is on. And so this one's also sucked to ground right there. So no current's going from base to emitter. Thus, it's not going to let any current go from collector to emitter. This is off right now, this one right here. So the pull-up resistor is not being interfered with, as you can see there. I can remove that jumper. But this one now is connected to ground because the relay is connected to ground right there. So it doesn't matter that we got the pull-up resistor. That's why we have a resistor. This is a direct connection to ground. So that resistor doesn't matter as far as that resistor is concerned. Hopefully that makes sense. And so yeah, coming back in, I have diodes that let the capacitor charge through one resistor, and then and the diode there, and then it discharges through this other resistor to pin 7 on both of them. So that gets duty cycle about 50% approximately. And if you absolutely need perfect 50-50, so that's high and low for a perfect amount of time right there when it's operating, there's ways to adjust that, but we're not going to worry about that right now. But yeah, these are both wired the same, so we got about the same timing right there. And again, that one is alternating right there, so we know it doesn't matter if I remove this jumper or not. It's not connected to ground. Although we do need this jumper to for the transistor, as I said before. So we technically can't remove it. That pull-up resistor is coming there, holding that one high, and also allowing current to go through the transistor right there so that it turns on and connects to ground on that side, transfers over, and comes up to pin 4 there, reset pin, for that 555 timer right there. So we do need to keep it wired this way, but sometimes if I have it set right, I can move a jumper without affecting things. Other times I cannot. But I just removed them for demonstration purposes right there. So, just as a reminder, this blue jumper is basically connected to the positive supply right there. It's always positive, but I'm not using it right now. Since, you know, these two wires and the supply there is using the same supply as the rest of the circuitry right there, we can either just connect to ground through this relay. It's all the same positive, so it doesn't matter if it goes through the relay or from the board right there. It's all coming from the same power supply. We can divert it to the wire, white wire, to ground when the relay is off. So I think the relay is off right now. When the relay is on, I mean. Nope, that's not going to stay lit. I was hoping it stayed lit when it was turned on, but it doesn't. Just lights up when I'm giving a signal. So now, I think I covered everything. So we're going to end it there. Hope you enjoyed. Make sure you check out one of the other videos I'm posting to the screen, and check out the links down below. They all help out a lot. I'll see ya in the next video.